We start with the quiz review. What I want to do is I want to do a couple of videos and exercises on chapter 6 because it's pretty new stuff. So we have this first exercise. Given the initial value problems in problems 110, use the improved Euler's method to obtain a 4-decimal approximation to the indicated value. First use h equal to 0.1 and then use h equal to 0.05. Now, we're going to go over to Matlab and do this, and if you are confused about the method that we're talking about, I believe I have done an earlier video about it. So please reference that. What we're going to do is we're going to do an improved version of Euler's method. That is, we're going to find a new y, based on our first y plus a linearization. So here we have the equation for the slope. So we can take the slope, evaluate it at the point where we're starting, which is x1, and then we're going to take that y and we're going to evaluate the slope again at the new x and new y by a step, which is given to us, and take the average of it, and that's going to get us a closer approximation to the actual solution of this. So let me go over to Matlab and do this. So right here, the first thing we want to do is we want to clear all old variables. So, well, let's put this is going to be less than 36 and 37, and it's going to be Euler's, so summation methods. So this is actually chapter 6.1, exercise 1. And the first thing we're going to do is we're going to clear all old variables. So that's done with the command clear all. Then we're going to define the initial conditions that they gave to us. So x of 1 is equal to 1, and y of 1, and I don't want it to output, so I put a semicolon. Y of 1, and y of 1, I'm just saying the first value, it's not a function. That's the first value of y is 5. And now I want to define a counter, so I'll use n, and I'll say we'll start from 1, and I'm going to define a step size, and I'll use the letter h, just like the book, and we're going to use the step size of 0.1. Then what we're going to do is I'm going to ask to define a while loop, because we're going to have to do the same thing over and over, and the while loop needs to have a condition. So my condition is that I want an x of, as long as my x is less than 1.5, which is where they asked us to end up. If you look at this right here, this is our final x. This was our initial. As long as we're below that, we want to continue the calculation. And then to end the loop, you just write end. Now we need to say what we're going to do inside the loop. So I'm going to define the intermediate y. This is part of the improved Euler's method, and I'll call this y intermediate of n plus 1, and it's really equal to y of n, which, as we're starting, we know our n is 1, so our y of n is going to be y1, and y1 is 5, plus we're going to have h multiplied by our the function for the slope, which is the one that we started with, which was, if you remember, open parenthesis, 2 times x minus 3 times y plus 1. Okay, now which x and which y? Well, this is x of n, xn, and this is yn. And yn, we're starting with n equals 1, so this is going to take out the values from this and this. And I don't want it to output, so I put a semicolon. Then, this is the second step, defining the actual y value. So our y of n plus 1, and actually to do that, I'm going to have to define our new x. So x of n plus 1 is really going to be equal to x of n plus h, because we're incrementing x by h. And here, what we want to do is once we have this, we're going to, this is our actual y. So that's going to be equal to y of n, the previous y, and again, we're starting from n1, which is going to pull y1, which is 5. And then from this, I'm going to multiply it by, I'm going to add h times this expression over here. So I'll just copy the parentheses from there. This expression over here. But then we're going to need another parenthesis here, because here I'm going to add the same expression, which is already in my clipboard, close it, and divide it by 2. Now, this is the value of n. Now we need to do n plus 1 and y int of n plus 1, because we are evaluating, we're taking the average of the slope. And I think I'm missing a 2. No, that's good. Okay, because this encompasses everything. Okay, and I don't want it to output, so I'll put a semicolon there. Then don't forget updating the counter. So now the counter is going to be what we had before, plus 1. We put a semicolon here, and then after the loop, if we want to look at the solution, we can ask it to, and hold on a second. If we want to look at the solution, we can ask it to plotting. So we can use scatter, since we're going to have discrete values of x and y. And then these x and y's are going to be vectors with one column and all of the values calculated in this iteration. So let's give it a shot. Press Control Enter. Let's see if we wrote everything correctly. I think I did something wrong in the loop, because it's not supposed to take this long. So let me stop it real quick. Let me go see in the command window what has gone on. See, it has never stopped. And I think it's because well, I don't know why. So let's go and figure that out. Let's clear here, and let's look at our x. Whoa. Okay, I didn't want to know all that. I just want to know the first few. So what's happening here? Our x is starting up. It's not changing. That's interesting. All right, so let's see what's going on in here. Our x starts here. So let's see if we define things correctly. So let me CLC so that I clear all of this command window. CLC, good. So now I just want to see, and that was correct, okay? Now what about x sub 2? And it added 0.1, so that's good. What about x of 3? X sub 4? X sub 5? So it just didn't stop. X sub 6? X sub 7? See, kept adding more to it, and that's what we don't want. So there's something. Oh, and that's because here I'm supposed to put an n. If I put a 1, it's always going to take this first one. This is always going to be true, and it's never going to stop. So let's try this again. Pressing here, Control Enter. Now we have something more manageable. We have something going down. And so x of 1 is 1. So if we want to know the last value, y of 5, or is that the last value? Well, let's print all of y. This is our last value. So we start from 5 and then we go down. 1, 2, 3, 4, 5, 6. But if we consider this to be the 0th entry, I know in Matlab you have to index it at 1. You can't have 0 as your starting value here. Well, actually I haven't tried it, but this is how I'm doing it right now. So this is your 5th value if you start counting from 0. So 0, 1, 2, 3, 4, 5. And I hope this was helpful. And let's see what happens if we do 0.5. Let's see what happens to this. Oh, this gets more points. Now if we print y, we see that we get improved results. And so this is why we always want to get a step that is very small. I hope this was useful, and I'll see you next time.